Welcome to qnawire.
Okay, we have the following molecule. We need to determine whether it is a cyclic conjugated system, and if it is a cyclic conjugated system, whether it is aromatic, anti-aromatic, or not aromatic. Now, the important thing to have a cyclic conjugated system is that all of the participating atoms in our cyclic system must be sp2 hybridized. Now, in this case, we can look to our borons with their 3 bonds and know that borons with 3 bonds always have an empty, unpaired p orbital, which means they are sp2 hybridized. In fact, this is what makes them such good Lewis bases or Lewis acceptors, right? They have that empty p orbital, and they are hypovalent, right? They only have 6 electrons around them, yet they're somewhat stable. So all of our borons are sp2 hybridized in this case, which is exactly what we're looking for. As for our nitrogens, note that each nitrogen is participating in 3 bonds, 2 in the ring and 1 to hydrogen. Furthermore, they each have a lone pair. Now, technically, these nitrogens can adopt multiple different hybridization schemes, but when they are in a system in which they can be sp2 hybridized, and there is some energetic benefit to that being the case, such as when they are in a cyclic conjugated system, they will in fact convert to sp2 hybridization, such that the lone pair on nitrogen is in fact in an unhybridized p orbital, meaning that each of these nitrogens has a lone pair in an unhybridized p orbital that is participating in the pi system that we are considering our conjugated system. Each of the borons has an empty p orbital. So since we have a system of overlapping p orbitals, we do have this cyclic conjugated system, and the number of electrons is, well, boron contributes 0 in each case, and in each case nitrogen contributes 3, for a total of 6 electrons. As for whether they are aromatic or anti-aromatic, recall that aromatic systems must contain a number of electrons on the list, which contains the numbers 2, 6, 10, and so forth, adding 4 each time, whereas anti-aromatic must contain the number of electrons on the list 4, 8, 12, 16, and so forth, adding 4 each time. Since we have 6 electrons, and that is on the aromatic list, our system is aromatic. Let's move on to our next molecule. Recall that our first condition is that every atom in our cyclic conjugated system, if it is in fact conjugated, must be sp2 hybridized. And here is where we run into a problem with this molecule. Because this carbon's not participating in any double bonds, we know that there are 2 implied hydrogens here, right? Which means this carbon has 4 bonds. Carbon with 4 bonds is sp3 hybridized. And in order for this cyclic system to be conjugated, we must have an unbroken chain of sp2 hybridized atoms, which we do not have here. Therefore, this is not a cyclic conjugated system. And so we would enter 0 for the number of electrons in that system. That's how this problem asks you to indicate that the system is not cyclic conjugated. For the final question, if it's not a cyclic conjugated system, it cannot be aromatic or anti-aromatic by definition, and therefore must be not aromatic.